Hi, my name is Tara Cosgrove, and this is my investigation for physical world. I chose to do stage 2 with the testable question of what happens to the speed of melting an ice block when we change the shape, material, and colour of the container it is in. This is also the title of the experiment. The aim of this investigation is to test which container enables ice to melt the fastest and which one keeps ice cubes frozen for longer. Materials and colours of containers differ in their ability to conduct heat. Ice forms when water freezes, and ice melts when there is a transformation of energy. In this experiment, the heat from the container is moving into the ice, causing it to melt. Scientists call cold an absence of heat energy. The hypothesis for this experiment is that ice cubes will melt faster in dark-coloured ceramic containers. Therefore, ice cubes will melt slower in light-coloured plastic containers. The shape of the container will not make an impact on the ice cubes melting. The equipment used for this investigation was a stopwatch app on a smartphone, but an actual stopwatch could be used. 8 standard ice cubes were also used, all of which were measured and were 2.5 centimeters on each side. There were 8 different containers for each ice cube to make 8 different conditions. The current investigation used a white china or ceramic dinner plate, a yellow frosted Tupperware container, a large purple silicone container, a tall plastic cup with a black interior, a white paper plate with coloured images, a cream-coloured egg cup, a Chinese noodle bowl with a black exterior and white interior, made of ceramic, and a clear glass cup. This experiment sought to engage fair testing to ensure valid results. Using the mnemonic cows move softly, meaning change, measure, and stay the same for the independent, dependent, and controlled variables. The independent variable was the type of container. The dependent variable was the time taken in minutes for the ice cubes to melt, and the control variable was the size of the ice cubes, which is kept constant for all 8 test conditions, as well as the temperature of the room in which the experiment was conducted in. To show fair testing, these images depict the thermostat and ice cube measurements, which were our controlled variables. The method for this experiment first began with setting the stopwatch app to accurately keep time in minutes rather than just checking the time. This ensured that the 5-minute intervals were kept constant for checking the ice cubes and taking photos. At every 5-minute interval, the ice cubes were checked, and if they had melted, it was noted from the stopwatch how many minutes it had been to the nearest 5-minute interval. A photo was taken at each 5-minute interval to look at progression of change. Once the final ice cube had melted, the experiment should be repeated at least 3 times to ensure accuracy and reliability. The times taken to melt should be recorded and the average for each of the 8 conditions found. Lastly, a graph should be created from the table of averages to visually depict which conditions were fastest and slowest for the ice cube to melt. This is an image showing the containers with their ice cubes in them. A number was placed next to each container to keep track of which one was which when recording the raw data. As mentioned previously, the average results of time taken for the ice cubes to melt in each condition was calculated and appears here. This bar graph is based off the previous table of results, depicting the average time taken for each ice cube to melt in each condition. From top to bottom, left to right, these were the fastest to the slowest ice cubes to melt on average. The results shown in the table, graph, and images that have just been shown show that the ice cube that melted the fastest was in the ceramic noodle bowl with a black exterior and white interior. The ice cube in this container, on average, melted in 40 minutes to the nearest 5-minute interval. The ice cube that was the slowest to melt was in the yellow frosted Tupperware container. On average, the ice cube in this container took 95 minutes to the nearest 5-minute interval to melt. To conclude the experiment, the hypothesis for this experiment was that ice cubes will melt faster in dark-coloured or ceramic china containers. Therefore, ice cubes will melt slower in light-coloured plastic containers, and that the shape of the container will not make a difference in melting speed. This hypothesis was correct, as the ice cubes that melted the fastest was in a ceramic or china bowl with a black exterior, and the ice cube that melted the slowest was in a yellow frosted plastic container. The hypothesis was also correct in that the shape of the containers did not make a significant impact on melting speed, as demonstrated by looking at the results. For the discussion of this experiment, I noted that dark-coloured objects are better conductors of heat, so ice cubes melt faster in them when compared to light-coloured objects, which are poor conductors of heat, in which ice cubes take longer to melt. The results also indicated that different container materials do cause a difference in melting speed, as most ceramic items were the fastest for ice cubes to melt compared to the plastic ones. The results further indicated the shape of the container does not impact melting speed. This activity could be repeated with other items that are known to be good or poor conductors of heat, such as thermoses and insulated containers such as eskies, which are made for the purpose of keeping cold and heat. The limitations of this experiment were that the data collected in this activity could have been more precise in that instead of taking photographs and estimating which ice cubes were most melted by looking at them, could instead be improved by measuring ice cube temperature change or by measuring the amount of water in each container. Further, not using 5-minute intervals for the accurate time taken may have also improved the reliability and accuracy of this experiment. The idea for this experiment was created by myself, and all the photos used in this presentation were taken by me during the process of the experiment. Thank you for listening.